Hello and welcome back everyone to the OpHaxor YouTube channel. It is OpHaxor Sam here with another solution for a LeetCode problem. Today we are looking at LeetCode 386, Lexicographical numbers. So let's go over the problem statement. Given an integer n, return 1 minus n in lexicographical order. So for example, given 13, return 1, 10, 11, 12, 13, 2, 3, 4, 5, 6, 7, 8, 9. So to kind of explain this a little bit, lexicographical order means that you're ordering by the digits with the leftmost digit given highest priority. So for example, we have, these are the ones digits here. So we go 1 and then 10, and then 11. So the second digit in 11, 1, is greater than the second digit in 10, which is 0. And then we have 12, and then we have 13, and it stops at 13 because our max is 13, which is the given. And then we go 2, but we can't go 20 or 21 because that's greater than 13. And then 3, 4, 5, 6, 7, 8, 9. So that's lexicographical order. Alright, so now we're going to jump into our Eclipse IDE to go over the solution. So here we have our main method, we have our base called method, lexicographical order, and then we have a helper method which is recursive. So let's go ahead and start a little debug session here with our debug here. Alright, so we're in the method. First we create an array list, that's going to be our result. So here we're starting out with the first set of digits 1 through 9. So I have a whiteboard in the corner here, here's where we're going to keep track of things. So our first digit that we're starting out with is going to be 1. Now, let's go ahead go into the helper method. So here's a check if the current digit, which is now 1, is greater than n, which is our maximum value, then we're obviously going to return. And that's our base case. So we always add the first one since we passed the base case. We're going to add that number, and then we get into our second set of numbers. So here we start with 0, right? So our new integer is going to be cur, which is 1, times 10 plus the I here. So that means it is 10. Right? And then we're going to iterate. Obviously that is not greater than or equal to n. And then we go again into the helper with the new int value that we just got. Let's go into that. So our number is 10. We check if that's greater than 13. It is not. So we add the number. And then we go back into another loop. So can you guess what this one's going to be? So we're going to multiply by 10 again and add I, which is 0. So we end up getting 100. Mark that in red. And obviously this will not be allowed. You can see it's 100 because it is greater than 13, so we return. And now we're back into the the initial iteration of this loop, which means our cur is 1, and now our I is also 1. So we do cur times 10, so 1 times 10, 10, plus I, 11. So 11 works, and I think you can guess what's going to happen here. In this call of helper, new int is going to be 110. So that will just return and nothing will be inserted. So we're just going to jump over that. Now we're going to go back in and now cur is still 1, I is 2, so we get a number 12. And let me go ahead and update the whiteboard here. Of course, we had 1, 10 rejected, and I think we get the picture here. And this basically is going to cover all the numbers up until 13. Alright, so here we have I is 3, so we have 1 times 10 plus 3, 13. That passes. When we call helper, it's going to give us the first new int value will be 130, and obviously none of those are going to work. And now we have 14, and obviously that's going to fail. So then we exit this loop or this call, and now we're back into this initial call of lexicographical order. So our next number is going to be 2. Let me update the whiteboard again. Alright, so now we're going to jump into helper for cur equals 2. We're going to add that number. And we will go into this loop. New int is going to be 2 times 10, 20 plus I, which is now 0, so we have 20. And obviously 20 is not going to work. So we're just going to return here. And it's basically going to be the same story for the rest of these numbers. Now we're on well, I skipped over it, but we were just on 3. So same thing as 2. 3 is going to be, 3 was just inserted. And then 30 and so on was skipped. And then we simply go all the way till 9. And we can see in our result array, it's 12, 13, we have 2, 3, 4, 5, 6, 7, 8, 9. Five, 6, 7, 8, and 9. And of course we had we had these whole slew of values, 20, 30, 40, 50, 60, 70, 80, 90, and so on, rejected, because those are all greater than 13. So that's basically how this works. It's relatively simple. This problem really showcases the beauty of recursion. And just for fun, let's have a high number. Let's put like 100. Let's see what we get. So you can see here, we go 1, 10, 100, and then you can't go higher than that. You can't go 1,000 because that is obviously greater than 100. And then you go back here to that base. So then you have 11, 12, 13, all the way up till 100. Or I'm sorry, all the way up till 19, and then you go 2, 20 up all the way till 29, 3, and so on. You go through every single digit until you get to the 9s, and then you go 99. Pretty cool. So that's basically it for this solution. Thank you for watching. Please like and subscribe. And please visit our website at ophaxor.com. Have a great day.